multiply and divide scientific notation. So this is actually going to combine scientific notation with the laws of exponents, because in scientific notation there's always an exponent on that 10. So let me just show you an example and then we'll write down the rules. Alright, so the example will look like this. 2 times 10 to the third times 4 times 10 to the second. Now, you could expand this out and then multiply it. That would be totally fine. But if you think about the commutative property, we could just switch all this multiplication around, right? This could really be written as 2 times 4 times 10 to the third times 10 to the second, right? Why not? Multiplication you can write in any order. So now what could we do? 2 times 4 is 8. 10 to the third times 10 to the second, that's the same base. So we would add exponents. So it would be 10 to the fifth. And that could be your answer in scientific notation. You would be done. 8 times 10 to the fifth. All right, so let's write down the rules here just so you have them. Something to refer to. So we're going to use the commutative property to rearrange the problem. And honestly, guys, sometimes you're just doing that in your head. Actually, most of the time. But that's, you can multiply in any order. Step 2 is you're going to multiply the first numbers together, right? That's what we did. Right? We got the 2 and the 4 multiplied together to be 8. Then you're going to use the laws of exponents on the tens. So use laws of exponents on the tens. And then last step, sometimes, if this number was bigger than 10, you might have to move things around because they're going to want your answer in scientific notation. So make sure your answer is in scientific notation. Okay, and that's it. It's really that easy. So let's try some more examples here. Keep the rules there for you. So we're up to example 2. Let's try 3 times 10 to the negative 7 times 9 times 10 to the third. Okay, so I'm just going to do the rearranging in my head. I'm going to do 3 times 9, that's 27. 10 to the negative 7 times 10 to the third. So negative 7 plus 3 is negative 4. Now, is my answer in scientific notation? No, 27 is too big. So here's the decimal point. I actually have to move it once to make it 2.7. Now, if I move the decimal once this way, I'm actually going to move the value of the exponent once the other way, right? Because if I expanded these out, this one I would move it 4 to the left. So 1, 2, 3, 4. I would get 0.0027. I have to get that same answer. So boom, boom, boom. So here's how I think about it, guys. If you move the decimal once to the left, think about the number line. I'm going to move a negative 4 once to the right to keep it balanced. So when you're changing a number and it's in scientific notation, you move the decimal to the left, you're going to move this exponent to the right for balance. And the reverse would be true also. If I move the decimal to the right for some reason, I would move the exponent down. Keep it balanced. Okay? All right, but this is our answer here. 2.7 times 10 to the negative third. All right, try another one here. 4 times 10 to the third and 6 times 10 to the eighth. Why don't you pause it and see if you can do this one? Did you really pause it? All right, I hope so. 4 times 6 is 24. 10 to the third times 10 to the eighth is 10 to the 11th. Is my answer in scientific notation? No. here was the decimal. I'm moving it once to the left, so I need to move my exponent up once to the right on the number line. So 2.4 times 10 to the 12th. All right, let's try another one. Number 4. Oh, right, we didn't talk about, hello, what is the title of this? Multiplying and dividing. We didn't talk about dividing. Let's see if you guys can figure this out. So if I did something like 6 times 10 to the negative 7 divided by 3 times 10 to the negative 9. I mean, you would divide the first number. So 6 divided by 3 is 2. Now when you divide and you have the same base, what do you do with the exponents? Hopefully you're remembering you subtract them. So this would be, what's negative 7 minus negative 9? Negative 7 minus negative 9. That's really negative 7 plus 9. So I get a positive 2. So this is my answer, 2 times 10 to the second. All right, so the dividing, I guess I could put in the rules here, multiply or divide. Right, and then you still use the laws, the rest is still the same. All right, let's try another dividing one. Let's see if I write it like this. 4.25 times 10 to the 6th over 1.7 times 10 to the second. Can I use my calculator for 4.25 divided by 1.7? I'll allow it. So when you do that, you get 2.5. And what do you get for the tens? That would be 6 minus 2, that'd be 4. Is that in scientific notation? Yes, it is. Okay. And we'll do one more. How about 4.5 times 10 to the 8th over 9 times 10 to the second? Pause it, see if you can get it. Did you pause? Okay. So 4.5 divided by 9 is a half, right? 0.5. 10 to the 8th over 10 to the second would be 10 to the 6th. Is this in scientific notation? Actually, no, right? That's too small. I'd have to move it once to the right, so it'd be a 5. If I move the decimal once to the right, I'm going to move my exponent down 1. Keep it balanced. 5 times 10 to the 5th. All right? Okay. Good job, guys.